Chief Engineer at DLT Apps, and I focus heavily on AWS and Azure Cloud. I've been working with both of them for quite over many years now. I started probably around 20 years ago in financial services, doing different kinds of, working in Java, .NET, and various technologies, and finally landed up in this sort of cloud technology space. So very passionate about cloud in general, infrastructure as code, blockchain, Golang. These days, experimenting a lot with Golang, and you'll see some of this as I go through the training course today. So in terms of the agenda for today, I'm going to just, I know that some people probably haven't used Terraform, so I'm going to do a quick intro, a very short sort of overview of Terraform and how to use it. And then move on to going through some of the basic terminology it uses, as well as finally focus mostly on how to build your provider, essentially, which is what the main focus of this particular session is. And I call it behind the scenes because it helps you understand how Terraform actually works in the background, because a lot of times engineers face problems on a day-to-day basis without realizing how Terraform really works. So hopefully this will give you an idea of the common failures and problems that you face. And then we'll just spend a couple of minutes on some of the key takeaways, summarizing that, as well as what's coming in next in the future sessions. With that, I want to just take you through some of the main prerequisites I would expect. I don't expect everyone to understand everything that from this, the list of prereqs, but it is helpful if you have some background in cloud services. So if you either work with AWS or Azure, for that matter, those are the ones I will be using in the future sessions as much, because that's where my experience lies. So some familiarity will help, because I would reference some of these services that that are available within the two cloud providers. A knowledge of IAC, infrastructure as code, and using either Terraform or something else is probably also helpful. If you use Terraform already, I'm sure some of this might be a repetition, and you'll definitely learn some additional things you may not know already. Obviously, I will heavily rely on using IntelliJ as my IDE, but I've also used VS Code. I use it on and off. So those two are sort of the go-to IDEs when it comes to Terraform and infrastructure as code, as much as I've seen. And then finally, I am going to reference Docker and container technologies mostly in some of these sessions, and from infrastructure provisioning perspective, not too much of virtual machines and sort of big, even Kubernetes for that matter. I won't go into provisioning of Kubernetes because it takes a while, and I would rather spend time focusing on just native Docker. So things like AWS ECS or the ACI container instances, or other resources I'll be playing with a lot when you further on session. Just basic knowledge, I think, would be sufficient for this. With respect to infrastructure as code, I mean, it's been around, I think, for forever. Early days, I think people used to use shell scripts and different Python and different kinds of scripts to manage infrastructure. But in general, the idea behind infrastructure as code is to manage your infrastructure stack. And I'll come to what a stack is shortly, using code and maintaining it in a version control system like Git, GitHub, Bitbucket, or even SVN and others are also useful as well. The main, sorry, was someone saying something? The main reason.
Carry on.
What's that?
No. You carry on, Mahesh.
Okay, perfect. The main benefits of infrastructure as code is the fact that it is repeatable, because if you have the code somewhere, you can easily repeat this and recreate the infrastructure that you had created previously, because it's in code. It's like a backup that you can run anytime. It offers traceability and auditability, because if you're maintaining everything from Git, or for that matter, any source control system, you can look at the history, who changed what and when it helps in troubleshooting, as well as just general hygiene around what had changed, because it's really difficult when you're looking through stack traces or logs, audit logs across cloud providers or infrastructures to figure out what had changed and who had changed that. So in terms of, because it's driven by code and it's part of your source code repository, it's much easier to manage and audit and trace to. And all of this brings in better speed and agility, right? So if you're maintaining your resources in code, it's easy to apply and faster to apply, which then improves the reliability of the system. So these are the main benefits I see of using ISE and what ISE is. I reference a lot stack. So to me, I just wanted to describe what a stack means to me. And, in general, I see a stack as a combination of cloud resources or I mean, not necessarily cloud, any kind of resources and infrastructure resources. So for example, a typical application on AWS or Azure or any of the cloud providers would have a DNS server, Route 53 or whatever else, some DNS records, a load balancer, some containers or virtual machine based applications, or any native cloud application services, Lambda functions for that matter, which then talk to a database. This end-to-end set of resources, which is each of those services, again, require multiple resources or based services to be created. That to me is like a stack, right? So being able to manage this stack is what I'm going to focus on in these coming sessions. And especially when it comes to the last session, you will see how all of this comes together and why it's important to think through this notion of stacks, essentially. So when it comes to technologies, before Terraform, obviously, there have been many other technologies, and they're still around. Puppet is probably one of the oldest, launched in 2005. Terraform itself was launched in 2014, but it really became, I think, went into GA with version 1.0 almost a few months ago, June 2021. So it's almost been around for 7 years, but was still in like minor versions, and never 1.0 was released almost recently. So quite a long history with various options. Again, they're all good options. One of the main reasons why I tend to use Terraform is obviously my background has been in programming, and objects and modules and inheritance makes a lot of sense to me. So when it comes to Terraform, because it's built on first off, it is simple JSON-like syntax, so which anyone can pick up. And then secondly, it is declarative. So basically, you're defining your end state rather than defining the process of creating the infrastructure. So it's just easier for anyone really to pick it up, essentially. And that's probably some of the main reasons. It also separates the plan and the apply phases, and you'll see some of the demonstration shortly around that. It helps manage dependencies, so it creates a dependency graph based on various resources you're creating on its own, and then make sure the resources that need to be created first are created before the others that are dependent on it. And the major reason, I guess, which I'm going to talk shortly about, is the whole idea of extensibility. Terraform has a provider-based framework which lets you extend and add and make sure you can work with any kind of APIs, honestly. So that plugin-based architecture bears itself really well when it comes to be it cloud or on-prem or any kind of infrastructure, which is again dependent on services that are API-driven. And needless to say, it supports multiple cloud providers, right? Because you can use it on AWS, you can use it on Azure, GCP, or any other private cloud. Even private cloud providers support it as well. So a lot of benefits. You still need to write the code again for every platform. So the infrastructure itself has to be built again. But once you know Terraform, you can build infrastructure in any sort of platform, essentially. One thing to bear in mind is it is great for bootstrapping and initiating your infrastructure, but it's not really a full-fledged configuration management. So like a typical Ansible Chef Puppet, where you can actually install the whole, complex stacks involving, say, WebSphere Commerce or web servers and stuff. That's not something Terraform is really meant for. So you may still need to supplement it with other tools if that's what you want to do. In terms of Terraform's core terminology, there are, I think, 4 concepts that you probably need to understand at a high level. So the first one's what you call is provider, which is this is the plugin-based model. So basically, when you're using AWS, Azure, GCP, or whatever other cloud provider, or for that matter, Docker or Kubernetes, each of them has a provider, and that provider manages all interactions between your code, your configuration you've written, and the actual provider of that interface. So whether it's a Kubernetes provider or AWS provider. So the provider is the glue that sort of executes your instructions. So when I want to create a resource, it's the one that makes an actual call to your API to actually create the resource. So that's one of the core pieces of the entire sort of extensible model. As of now, I think there's probably 1,500 or so providers on the Terraform registry, and it's obviously constantly growing. So have a look at many of these. I mean, Kubernetes is already supported. There's multiple databases also. You can use it to manage database resources. Kafka has a provider as well, along with other providers. So that's what a provider is. Everything starts with the provider, basically. The next level down is when you decided what the kind of provider is, what the APIs you're interacting with, you then create resources. So resource is a unit within Terraform. So basically, a virtual machine or a container instance or Docker instance or a load balancer, all of these are resources. So these are what you provision as part of your Terraform. You can combine multiple resources in what is called as a module. We will talk about this in the following session, not today. But again, think of it as a container that includes multiple resources. And then finally, everything that you manage, Terraform internally keeps a state, a backup of the state of what was executed last. And that's what is one of the critical things that I'm going to also discuss today as I go through the provider. So those are the four main things that you need to understand when you're using Terraform. Now, the other thing is when you are writing your Terraform, you must have seen multiple Terraform files, right? TF files, essentially. The basic one of the most basic things you would see is the top of is the provider, essentially, as I said previously. So in my example that I'm going to show run shortly, I am actually using the Docker provider to create a Docker instance or Docker container on my machine using Terraform. So the first thing here I need to define is the provider itself. So I'm using Docker provider, which is then pointing to my local Unix socket, Docker socket, which is what's going to be used to execute instructions against my Docker daemon that's running on my local machine. I am going to deploy, in this sample, I have Nginx image, which I'm going to pull from the Docker Hub, and I will then run it on my Docker daemon, my local Docker instance, and expose it on port 8081. So that's the simple example I'm going to show to demonstrate how Terraform works. And to get this running, basically, there's a three-step process at a high level that Terraform uses. So when you've written your Terraform code, and I'm going to show you where I've written it, the first thing you do is you do Terraform init, which basically all it does is because you may be using multiple providers, it goes through the list of providers, the modules, and creates a cache of all of that locally in your working directory. It also creates sort of a map of the backend state and a few other things which it needs to before you run the actual Terraform. The next stage is the plan phase, which is where you try to see what are the changes it's going to apply. So this is more like a review stage. So when you do run Terraform plan, it will execute most of the resources and try to use the provider, make the API calls, and then try to see what is the set of resources you're trying to create. Are they being created for the first time? Are they already existing and does it need to update? Or are there resources that you need to delete? So it identifies all of that and shows a plan to you. I will talk through how to go navigate that plan as well shortly. And then finally, you apply this change. So apply is the stage, which is basically making those changes on top of your and applying the infrastructure changes itself, which basically uses the plan, essentially. There's also a destroy stage, which is typically used when you want to clean up everything and start from a clean slate. So whatever's in your Terraform configuration, it will just delete it using the delete APIs. So with that, I will just switch to my IDE and just quickly talk you through the code base. Can people see my screen, the IDE here? And is it legible enough?
Yes, it is visible. It is visible.
Right, okay. So in here, I've got some Terraform code, right? Again, the same code that I showed earlier. So I've got a providers TF, which has my provider. This is pointing to my local Unix Docker socket. I can also show you the Docker desktop that's running on my machine. As you can see, there's a kind cluster running. So there's that one, and I have a PostgreSQL a container running as well. Now that's the containers that are running. So this is the initial setup. This is, again, you'll find all of this on the Terraform registry, how to use the provider. Basically, it's from this particular institute or something. And then what I'm going to deploy, and as I said, is an Nginx instance. So this first resource pulls the latest Nginx image. I can also pin it down to a version if needed. For now, I'm just pulling the latest. And I'm going to create an instance of that image on my machine and expose it on port 8081. So if I now show you first, if I show you nothing is running on port 8081, it's basically, this is not found. So that means there's nothing running on that service, on that particular port. I also have another resource, which I've commented it out for now. I will just run it later on to show you how this particular Terraform works with addition of resources. So as I said, the first step is Terraform init. So I run init. As you can see, it says, if you go through the list of steps it provides, what the first thing it's doing is going to finds the provider, the version I've mentioned, downloads it. And then if you are curious enough, you must have seen that it has created a few files in here. So if you see this Terraform folder, and if you expand it, you will notice that it has already downloaded the Terraform binary from the plugin binary. So this particular Docker provider that I was using, it has downloaded the file and put it in my local cache, essentially under a .terraform folder, basically. And it does that for every single provider that you use. So that's one thing. The other thing it has done is also created an HCL log file, which is, again, just information about the provider, the version I'm using. If you use modules, multiple providers, you'll see this list longer and growing, essentially. It is auto-generated as well. This is just a way for Terraform to keep track of what sort of versions you've used when you sort of, ran the Terraform commands previously and applied the infrastructure. So with that, so I'm done initializing. So the next step is apply the plan. So view what are the changes that's going to be applied here. So if I do Terraform plan, you will notice that it's given me some information about what it's going to do. So you will see that there is some handy notes at the top that says anything that's been created will be marked with a plus here, highlighted in green, essentially. And you can see the two resources, Docker container and the Docker image, are the ones it's creating. So let's quickly go ahead and apply that. Again, when I apply, it shows me the same changes again. This is just to double check before you apply, and ask for confirmation. Once I say yes, it should soon enough, it should bring up the container on my Docker daemon. So there you go, it's done, added the two resources. And now you can see that Nginx port has been created. Now, if I click on this, I'll link here, and there you go. So Nginx is up and running on my local machine. If you remember, I had this other container, right? So now if I go back and let's say uncomment this change and try to sort of add that and run the commands, run the same commands again. Although I don't need to do init again because it's the same provider, but just showing you. So if I do Terraform plan now, if you you'll notice that it is creating the Apache container, so that Docker container, and it's also going to pull the Apache Docker image. So those two are the net new additions on top of what is already deployed. So it is, as I said, it is smart enough to basically identify the changes that are already there and that need to be applied. So if I go back, the one other thing I want to show you is the state file. Since I did apply, it has created a state file here, and it's got the two instances. So a Docker container called Nginx with all its attributes, and then it also has a Docker image for Nginx. These are all applied already. So now this change, if I apply that change, which is the Apache container apply, it will create the Apache container image. So should be shortly. There you go, it's done. So if I go back, now if you look at this Docker UI, it shows Apache is running, and if I click on the web application, so there you go, it's up and running. Now, the Terraform state, if you look at the Terraform state now, it should show you the 2 additional resources that have been created, which is, so basically I've got Apache Docker container and the Apache Nginx container, and the similarly the Apache Docker image and the Nginx Docker image. In this session, I'm just keeping the state locally. In the future, you will see how to maintain this state on an S3 bucket or the Azure Object Store or somewhere on the cloud, essentially, because it's a bit risky to keep the state locally on my machine. But since this is an intro session, I'm just keeping here locally. So that's it. As you saw, it creates just the net new additions and updates that you require. Now, what if I delete one update? Let's say I just go ahead and delete this Nginx, right? Accidentally, for example. Let's see what Terraform does in this case. So Terraform plan, and there you go. So what it says in this case, it's curious. It says 1 to add and 0 to change. Does anyone here know why it is just saying 1 instead of 2, like it was doing previously? Is everyone listening? Yes, so yeah, that's a good point. Yeah, so basically the Docker image, I think it was Puru, said the image is already downloaded, so it doesn't need to download the image. It's already cached. All it is going to do is deploy or run the Docker container. And so basically it's only saying it's going to add 1 because I had deleted this from here. So if I do Terraform apply now, I can also do auto approve, which means it won't prompt me for the change. And there you go. It's added it, and my Nginx container is running up again, right? So as you can see, it keeps a track of the changes that have happened and automatically creates the resources for you, which is really the beauty of Terraform. So now let's look at how this happens. And this is where I'm going to use a sample provider that I've created. So the basics of building a provider is basically overall how Terraform works internally, right? So there is 3 main concepts, I would say, and all of this information is on the Terraform documentation site. But in general, you have a target API, so which is what you see here at the right. So you've got your AWS APIs, Azure APIs. In my case, I have my own API. The target API is what is actually doing the actual changes. So in my case, when I was running the Docker container creation and updates and stuff, there's an API which is actually underneath the hood, creating the Docker image, pulling the image and all of that. So this is the one that's actually doing the job, and this is what is being called at runtime when you run the apply instructions. And then there is the Terraform core, which is the core functionality Terraform provides, which is just basically when you do Terraform init and pulls down all the cache of the providers, it generates a dependency graph based on what resources you're creating, all of that. So that base functionality is in Terraform core. And then you have this area in the middle, which is all the providers and the plugins. So the core Terraform product doesn't really change. I mean, it does change over time with some enhances to how states manage and all of that, but it doesn't. It is sort of a static thing. And you have the target API, and the plugins are the ones that bridge the gap between the two, essentially. So this is why you have a provider for AWS, you have a provider for Azure, you have a provider for MongoDB or Kafka or whatever for that matter. Now, in my example, what I'm gonna show you is a sample web service I've created. So I have a service called for school management. So think of it as a school administration sort of functionality, right? So if you had a list of schools to be managed, so basically, school, any sort of, state level, international, or whatever library, a school management system that you have. If you had a web service that helps you create, update, delete schools, this is that particular service, right? Now, it is a very basic service that uses only five attributes basically. So ID is auto-generated identifier for the school. Every school has a name. I expect a country associated with it, city, address, and then a list of contacts. That's as basic as it can be. This is just to demonstrate how to create a provider. Real life services, I'm sure, are much more complicated than this, but I think this will help you understand how this really works. And then I have a bunch of APIs. So these are the APIs. So basically you have a create school API, which is on this API endpoint, which supports post. And then there is a get API, there's an API to update, and then there's an API to delete. This is as small as a sort of functionality a service needs to provide for you to create a Terraform provider. Now, before I go ahead and show you the actual provider, let me actually show you the web service, right? So in my case, I've used Golang to create this small scrappy web service. So it's running locally on my machine. So this is the actual API. It's running on 9,000. If I just make some API calls, so this is the first call is basically to get a list of all the schools. So basically right now there's no schools created. If I go to the post, this is the post operation, so this will create a school. So if I just say, invoke this particular API, it's just created a school. If I go back to get, you will notice that it's created that particular school in here with all the information I had provided. There's also get function, as I said. So if I do get, it returns that particular ID. If I just try a school that doesn't exist, it'll say school not found. And then there's a delete, which I can obviously use to delete. So if this, I want to delete number 1, which I just created, I'll just do that. It says status is true. If I run it again, it'll say false because it failed. And that basically has got rid of my schools basically from that particular API. Now, this is as simple as the API is. I'm going to try to use this to then create a Terraform provider. So where do you begin? So the first step is to, now that you have an API, the first step is to define your end state. So what does your provider look like? What are the attributes your provider is going to support? So in my case, I'm running a web service. It could be running anywhere. So the first thing I want to give the provider is the URL. So in this case, since it's running locally, I'm just giving the local host 9,000, which is my port, but this could be anywhere around the world, right? So as long as it supports the same sort of interfaces, it should be okay. In addition, you can provide credentials here. So like the AWS provider, for example, takes AWS profile, AWS key, access key and stuff. Similarly, Azure provider supports credentials as well. So you provide your context for that particular provider that you need. In my case, I'm just going to say simple URL, and that's all it's going to use to then make API calls to that particular API. And then you define your resources. In my case, there's only one resource, which is a school. And now if this web service was bigger, it was managing buildings of schools or, locations in the school has multiple locations to manage those or stuff that are associated with the school and all that. I could have multiple resources, but for now I have a single resource, which is school. So in this case, it'll be school management entity in the school is going to be how I create the schools essentially. And then these are the main attributes that you provide as part of particular your Terraform resource. So this is how I'm going to expect users of the Terraform provider, my provider, to use the resource. And this is what you should define first. Now, once you've defined your end state, you can then build your provider. Now, there's only a few main files or sort of code sort of concepts that you need to be aware of when you're writing a provider. One of the main things is this is all written in Go typically. So all this, you'll see a lot of Golang code in here. If you do not know Golang, obviously, I'm sure there is a nice website with Golang by example, which gives you some basics of it. You don't need to know heavy duty Golang, but you need to understand at least some basics. But in general, a plugin, a Terraform provider or a plugin has the following structure. So there is a main function with main.go or a main class as used to be in Java, which initializes the provider, which just to initiate the plugin. And then you have a few classes, a few classes within your code base to do certain things. So you have a provider.go, which then initiates the provider configuration. So the URL I mentioned and some other attributes, you configure that in your provider. You have a client which then interacts with your APIs underneath. This is just a standard HTTP client. You have a proxy for all the API calls. So you have, as I said, you can create a school, update a school, delete a school. All that is in your schools or a class that manages all those APIs. You have to define your model, the structure that I mentioned, what are the attributes of your particular resource. So that's in typically written in models. And then you have your resource files, which is where the actual functionality of a particular resource exists. I'll just switch quickly to my code again, and I'll just talk you through this code itself. So I think just to bring it to life. So as I said, this is where the provider code is. I mean, it's pretty simple. It's not a complex provider. So all it's doing is initiating the provider. Now, if I go to my school module, this is where I've got some of the underlying classes. So the client is basically, as you can see, it's just an HTTP wrapper to invoke various functions to make the API calls. Models is where I've defined the main attributes. So as I said, a school will have an ID, name, country, city, address, and contacts. ID is auto-generated and it's managed by the resource. The others are obviously something that people can enter. So you just define that structure in here. The provider file is sort of the glue that brings everything together. So as I said, in here, I've specified that my particular provider expects one parameter, which is the URL, and it's specified. It can also be picked from an environment variable school management URL. So you don't have to specify it in the provider. You can also specify it as an environment variable. And then you define your resources. In my case, there's only one resource, which is school. So that's the resource I've defined. And that resource is defined in further on in this resource school class, essentially, which I'll talk about shortly. And then there's some use standard sort of code that you need to initiate the client, HTTP client that I talked about. I'll just switch to the schools first, and then come back to the resources. So this schools is like a proxy, as I said. So this makes all the calls. So it's got get functions, which is making the API calls. There is a create school function, which again makes API calls to the post API calls and so on. So all the functions that I had, which I was showing you on Postman, are basically invoked from this particular class. So it's like a proxy or an API interface. And then finally, I have the actual resource. So this is the actual place where the logic is specified. As I said, ID is auto-generated, so it's not supposed to be entered within the Terraform itself. It's mainly maintained internally. And then the other parameters are what I have specified in the schema. The main thing, honestly, is these functions. So you've got a create function, you've got a read function, and the delete and update. So this is like a typical contract that a particular any sort of resource needs to perform. The only example I think I'll cover here is, I think create and read are probably straightforward. But if you look at the changes, the update one, so there is this logic in here which basically looks for any changes in this particular attributes. And if there is any change, it will make the API call. So this is how basically Terraform, when I was showing you the Docker examples, right? This is how it understands that an attribute has changed and it needs to apply that change essentially. All of that is actually scripted. Now, based on a provider, you may be looking at certain attributes and may not be ignoring certain attributes, all of that. So that logic is what you need to define in your resource, basically, to be able to create or update based on the logic you want. Now, that's what the provider looks like. Now, I've already built this provider and put it in my local plugin. So I have a small make file here which does that. But basically, it runs go build and then it puts the output of that particular binary in this particular location, which changes based on the type of laptop. So if you're on Linux, it'll be a different folder. If you're on Windows, it's a different folder. But that's what it does. It just puts it in a particular folder, and the plugin is there for me to start executing my Terraform code. So that's how a provider basically works and is written. Now, once you've written the provider, you write your Terraform and then you basically test it, right? Essentially, that's what as simple as it is. So again, with the actual code, Terraform code, you have a providers and main TF, which is what I'll show you quickly here. So this is my example for Terraform for the resource. So if I quickly navigate to the providers, as you can see, I have mentioned this provider management. It's pointing to my localhost 9000, which is where my API is running. I've mentioned that this particular provider is under a particular structure, which is where I put it in my plugin folder under my local directory. So if I were to do this, plugins, so EDU, tool management. So this is where my provider is. So basically, it uses this and tries to figure out the path for that particular plugin. I have to do this just because I'm in a local testing phase. Once this is done, tested, it can be published to the registry and you can pull it from there. But because it's all local, I'm just using this particular explicit sort of mapping and copying files. So that's my provider. And then in my main.tf, I've got a few resources. So I've got, I'm creating this one school in early UK. There's a school I'm trying to create within India. And then there is another school, third school I'm trying to create. So just for fun, what I'm going to do is I'm just going to, comment out this third one, and I'll show you how this is how the logic for identifying changes basically works. So I'll also, for now, I'll switch the contact details to a UK school. Although this is a school in India, I just want to show you later on how this change can be is applied automatically and identified automatically by the code. So that's it. I have the code here. So what I'm going to do now is I'm in that directory, so in the example directory. So as I said previously, the first step is Terraform init, which I'm going to run. As soon as I do that, it basically finds out the provider. So it's looked up, the provider is here, and it's copied over the provider. So just like previously, it must have, and it has already created this local cache, right? So you've got the provider in here, the school management provider I was just showing you, it's created a link to that particular provider on my local machine. So it's done that. It's also created this HCL file, which is also pointing to the version of the provider essentially. So exactly same as the last time. So once I've initialized, let me do Terraform plan. And if you look at the plan now, it says it's going to apply these two changes. So it's creating two resources. So basically the two schools, I have commented out the third one, and the details of those schools it's going to create. So I'm happy with that. I'm going to say Terraform apply, auto rule. And that's it. It's created the school. So let's go back to Postman and double check whether it's created them. So there you go. So as you see, it's created schools 2 and 3. Number 1 was already created for the previous one, which I deleted. So it's just incrementing the numbers there. So there you go. It's actually executed the same APIs using the provider, and it's created the resources on my local API. So as a next step, as I said previously, let's go back and try to fix the two changes we made. So I just realized, so as I said earlier, I had this change, the country of this particular school was incorrectly entered. So let me go fix that. So I go back and I'm putting in the details for India. I'm also going to remove this third resource, which I had commented out. So now what it should do is basically it should tell me that it's updated one change and it's adding another resource. So if I now do Terraform plan, as you can see, it says 1 to add and 1 to change. And that's because it's automatically, because of the APIs, it's identified that this particular school with Yamandir has a change in its address, city. I mean, in my case, I've changed all of them. So, it's showing all changes, but if there was some attributes I hadn't changed, it would show them as well. It also notices that this is an array, and in this array, I have removed this particular item and I've changed it to this particular from Tom to Vignesh. And then there is the second resource which I'm adding. You can also see it uses different sort of colors for highlighting the types of changes. So addition versus, updates basically. So that's it. So I'm happy with that change. So let me go ahead and apply the change. Again, it's done the changes. And if I go back to my Postman and look at the output, so there you go. So this had no changes, so it's fine. It's updated this school, so it's got India details now. Yeah, and then it's added this fourth school, which is St. Joseph's, which was basically not in the previous one. So that's it. And then finally, I can go ahead and destroy, which again would go to the same thing. If you look at the plan again, so as I said, even destroy previously, I think I forgot to show you, but it also shows the plan before you apply the change. So as you can see, all deletions or destructions are in this red hyphen, and it's going to destroy all of these resources that have been created. So if I say yes, there you go, it's destroyed all of them. If I go back to my Postman, they're all gone. So all the resources I created are all gone. And that's about it basically. This is how you create a basic provider and basically use it essentially. So what have I covered in the past like 40 minutes or so? So we talked about basics of infrastructure as code and Terraform. I hope you appreciate the use of this, how you can identify the changes easily. I also talked through why Terraform probably is my at least go-to platform compared to frameworks compared to some of the others. And you see some of that in action. I did talk about the basic terminology, which is a provider, which is actually the plugin set of plugins, which then talk to various APIs. I talked about what resources are, basically as the smallest unit that you create using Terraform. And then modules is something we did not discuss today. We will pick it up in the following sessions, but it's a combination of multiple resources that you manage together. And then finally, there is a state file that it sort of maintains as you're applying the changes, essentially. This is a way for Terraform to check what was previously created versus what exists now, essentially. I showed you a sample using Docker to how to run all this. And then we went through the key stages, which is the initialization, plan, and apply. So init is basically what is used for pulling down the various resources, modules providers and modules you're using, caching it locally, and then plan is where it creates a dependency graph and then shows you all the changes that are being made and then applies them. We touched a bit on the Terraform state. We didn't dive too deep in it. We will come back to Terraform state in the future session a bit more, but I think I've showed you enough around what are the different fields it maintains and how it tries to map what is in the state versus what has already been created. But for every run of plan and apply, a Terraform state is created basically or updated. And then we talked through how to create a provider. So as I said, you start with the target API. You have to have an API that supports CRUD. So create, read, update, add and delete, update and delete. And then you use that to define your resources you want to create, the structure of the Terraform provider, and then you basically write the code in a mechanism I just showed you. And that's it. And then you can start using this Terraform code. There are some useful links on this page as well that you can use for future references, and I'll be sharing this content shortly as well.